So unless you're an academic or a scientist, you may be only vaguely aware of the National Institutes of Health, but this is called the crown jewel of American science, and it is truly the envy of the world. And as somebody who trained overseas for part of my career, I can tell you that this is indeed the case. So what we're going to do today is we're going to learn about the NIH. We're going to learn a little bit about how science in this country, biomedical research in particular, works. And we're going to learn about what's happening right now, why you should care, and what you can do. Because what I really want you to take away from this is yours. NIH belongs to you. You've paid for it, you've paid for the research, this is yours, and we need you to be an advocate before anything further happens to it. All right, so let's talk a little history. NIH really got its start with the Marine Hospital Service that was established in the 18th century because you needed to screen all those sailors for whatever weird tropical diseases they were bringing in. That became the Laboratory of Hygiene, founded in New York, which was really an important microbiological research center. They isolated the first isolation of the bacterium that causes cholera, for example. And recognizing that this was something that had national import, it moved to DC in 1891 and was renamed the National Institute of Health in 1930. And this 1910 beautiful Georgian building still stands on the NIH campus today. What really happened that created American science as we know it was World War II. The scientific process became clearly important to American security and well-being. Think of it, this was the dawn of the age of antibiotics. Of course, you all know about high-energy physics and the dawn of the nuclear age. But in 1945, presidential advisor Vannevar Bush, who, by the way, was the dean of my alma mater, MIT, made a report called Science, the Endless Frontier. And he advocated in that report that rather than having private laboratories or government laboratories, the government should put funding into the universities, which would not only generate important research from a variety of points of view, but would have the additional effect of educating the next generation. A component of this was that there should be a competitive research grant system that was based on merit, and he established the National Science Foundation, which is not our topic today, but is also important in that process. And FDR liked the idea, and that is what really founded American science, this agency and partnership between the federal government and the universities. If we look at, this is the portfolio from a couple of years ago. Overall, the government spends over $200 billion into universities and a variety of science. And you can see here, the publics are in orange, the privates are in purple, and you can see just a few of them highlighted. Look at just our University of California, San Diego, our neighborhood public at 1.1 billion. All right, so this is the current partnership. And if we look at what's happening across the world, we can see the United States by far spends more on research and development than anyone else. The second here is China, which has, of course, a much larger population than we do. So we have an outsized impact in the science that we're funding. And of course, nearly every technological development, ranging from the smartphone that you use to state-of-the-art vaccinations and so on, all comes from this federal investment. Let's go back to the NIH. It was renamed the National Institutes, plural, of Health in 1948, and they built a clinical center in 1953. In 1980, the Department of Health and Human Services was created, and NIH was folded into that. The main NIH campus is located in Bethesda. It is a mecca for biological science. It is the most amazing place. It's huge. There are thousands and thousands of investigators all studying all aspects of biomedical science. They have satellite campuses in Frederick, in Baltimore, and in the Research Triangle of North Carolina. And there are currently 27 institutes and centers that comprise the overall NIH. There's a robust research program in Bethesda and on the satellite campuses with about 1,200 principal investigators. Think of those as people like me, the equivalent of a professor, and about 4,000 postdocs who come from all over the world. Now I need to tell you about a postdoc. A postdoc is a scientist who has a PhD, is doing advanced training in somebody's laboratory. You could consider it sort of the medical residency equivalent for a scientist. These people come from all over the world. because this is a center of excellence. That excellence is maintained by regular, rigorous external reviews where scientists who are experts in the fields of those investigators are brought in every 5 years to review the program and recommend funding. The Clinical Center at NIH is the largest hospital in the world dedicated to clinical research, nearly 500,000 trial participants, many lives saved, rare disease research that just doesn't happen anywhere else, as well as state-of-the-art clinical stuff. And that's pretty impressive. But that only accounts for 10% of NIH's $50 billion budget. 80% of the money leaves Washington and goes to the universities, hospitals, medical centers, research institutes around the country. 80%. And so what I'm going to tell you now is about how that process works. Now that money spread around, I just want to point out in California, that's almost 10,000 individual projects and over $6 billion of NIH funding that just come into our state. And there are resources listed on the handout that will tell you how to look down to the level of understanding how much of that money impacts our county in San Diego. NIH funding contributed to over 99% of the new drugs that have been approved since 2010. In the last 40 years, deaths from heart disease down 75%, deaths from cancer down 30% just since 1991, in part because of the discoveries made at NIH. 90% reduction in perinatal HIV infections. Revolutionary new gene therapy treatments that come from work that was originally done by NIH-funded investigators studying strange features of bacteria. Over 174 scientists with NIH funding, either intra or extramural, have earned a Nobel Prize, with other investigators earning numerous other prizes. Over 1,000 new science-based startups every year, and every $100 million spent leads to about 76 patents. There's an economic impact that is enormous. Every dollar of NIH-funded research generates about $2.50 of economic activity in its vicinity. Just think of the economic activity that's generated by having hospitals, medical schools, and universities in the community. Over 400,000 jobs nationwide, over $94 billion of economic activity that is not directly funded by NIH, but a result of NIH funding. NIH is by far the biggest funder of biomedical research in the world. This is a comparison of NIH on that top bar there to the nearest as the Wellcome Foundation, which is nowhere near. So this really is the crown jewel and has been the driver of biomedical research, not just out here, but across the globe. And I really want to stress that international component, because we'll get to that in a minute. Now, the meat and potatoes of NIH funding into the extramural community is what we call research project grants. These are grants that are given to individual investigators through their institutions to do a variety of research, from the most basic, like mine, to more clinically oriented research. The principal investigators, the people who are in charge of the grant, are professors like me. They must have the equivalent of a doctoral degree. They must have the equivalent of a faculty position. They must have an institution. You can't write a grant from your garage. And in fact, technically, the grants are not given to me, but to my institution. All right, so what is a grant? A grant is not a contract. A grant has no promise of a deliverable at the end of 5 years. A grant is, I am pursuing knowledge. I have an idea. Sometimes the most important thing is to determine that that idea is not going to work. And the analogy I like to use for this kind of science is walking through a tunnel with a torch flickering in your hand, looking to see what you can find. Maybe the tunnel's a dead end. Maybe you narrowly avoid falling down a deep shaft. Maybe you find some incredible ore in the wall. Ultimately, you hope that what you find will be important, even if what you've learned is don't go this way again. That's very important. Being wrong is part of the deal. Scientists change their mind a lot. We don't form opinions based on what we want to be true. We form opinions based on convergent evidence. People can be disconcerted by the fact that we will change our minds if we get different data. And sometimes we're not very good at communicating that that's part of the process. Eventually, you hope that you'll find something important enough that the guys with the big arc lights and so on will be able to come in and take advantage of it and turn it into something that helps everybody. But it starts with the idea of a grant. So how does this process work? You start, as I said, with an idea, maybe a little bit of data. You've honed this idea from some experience, from discussion, and you think, okay, I think this is ready for some funding so I can really push and see if this tunnel is going to go anywhere. So you write it up as a research grant with a detailed research plan for 4 to 5 years of research. This includes not just the research plan, which is what I'm responsible for writing, but a lot of paperwork, biography of all the investigators, budget, regulatory compliance, and so on. And I want to introduce your Canon Verger as the Senior Director of Grants Administration at the Salk Institute. That's the part, the rest of the grant is what she's responsible for. Yeah, we do multitasks here. All right, you get a grant, you send it to NIH. Typically, there's about 3 deadlines a year when NIH will receive grants. And those grants will cover everything from microbial research to cardiac development to drug therapies, right? So everything, a huge, huge spectrum of science. So how do you figure out what's good? Well, the essence of NIH is something we call peer review, which is people like me and my peers who are assembled into peer review panels or what we call study sections in their area of expertise to review the grants that were submitted to NIH for that deadline in that area of expertise. And as you might imagine, there are hundreds of study sections in each round. The study section will be about 20, 25 people. It'll get 50, 100 grants to review, and everybody will read those grants, or the 3 people will every grant will be read by at least 3 people in detail. And then after the grants are read and preliminarily scored, the study section will meet and everybody will discuss the grants. Did they think of this? Hey, what about this? Well, I think this is a great idea. All right? So they'll sit and discuss them, or at least they'll discuss the top half. And the criteria they use include, is this a significant idea? Is it going to advance science? If it works, and remember, it's not a guarantee, but it's like, this is a good idea. Are they taking the right approach to this problem in terms of the conceptual or the framework? Is it innovative? Are we moving things ahead? Are we moving things forward? Does the principal investigator have the qualifications to do this work? Have they assembled the right kind of team? Are they in the right environment to do this work? These all go together in establishing a score. A little dark scientific humor here says, is it just me or are these review panels getting a lot tougher? Because what's going to happen is that they're going to score the grants, and then what will happen is all the grants for a particular institute, remember there are 27 different institutes, all the grants for a particular institute from all the study sections reviewing that institute will go to that institute for another level of review, which we call council. And again, this is senior investigators from around the country as well as internal NIH staff. I want to point out that most of the NIH staff running this stuff also have PhDs. These guys are going to determine, of all the grants that came in from all the study sections of their institute, how they're going to rank order them and what the pay line is going to be. And the pay line is typically 10 to 15%. All right? Percent. Oh, how many are going to get funded? Okay, thank you for that question. Right, 10 to 15% of the grants reviewed in a given round will be funded, which means 85 to 90% of those grants will not be funded. Okay, that's my world, people. So what will happen is that they'll figure out, okay, we can afford to fund these guys. So the rest of them will be unsuccessful and they'll have to try again. Maybe and this whole process has taken about 9 months. So you get your scores, and it's like, oh wow, remember 3 deadlines a year? So you can't really realistically submit a project more than once a year. So maybe you have more data, you get the reviews and say, oh, hey, here's an obvious thing that I missed, duh, this kind of thing. Or maybe you close your lab. I've had a number of colleagues who have been unable to get a grant, and after a year or 2, there's no money, and goodbye. You don't get tenured without a grant, And let's just say if I'm not getting grants and doing research, my profile at the university changes. I teach, I do research, but if I don't get funding, I have to go to a teaching-only profile, lose my lab, and teach only. So this is very competitive. If we look at the statistics, there's many more ideas than funding. This dark line is how many grants they get. This lighter bar is how many are funded. And the success rate overall, NIH calculates at 20% because there's some different mechanisms, but realistically for a research grant, it's 10 to 15%. Now I will tell you, as someone who has reviewed grants for NIH for years, that the top 25% of grants, there's really very little difference. I could throw them down the stairs of the top 25 and pick any few of them and know that they would be fine. All right? Remember, everybody's got a PhD, everybody's got a faculty position. We're not just funding crazy people out of their garage. So there's a lot of really, really good work that doesn't get funded. And this has been a problem for years because the other thing is that the size of a grant hasn't really changed in 15 years, but I'm going to tell you everybody's salaries and costs have gone up. So this has been an issue too. And we've known that, and we've seen the consequences of this. This is a graph showing you high-impact research papers up to 2022, and you can see the number of high-impact research papers originating in the US are starting to go down, and the high-impact research papers coming from China are going up because China's continuing to make a much more significant investment in research than we are. This is where we were on January 20th. We have some problems, we need to work in this. But typically, NIH has enjoyed robust bipartisan support because, I'm going to tell you, cancer doesn't look at whether or not you're a Democrat or a Republican, all right? Heart disease doesn't look at whether you live in a red state or a blue state. So everything we were aware of some issues. Things were challenging. That 10 to 15% success rate has been really killer. But that's January 20th happened. 3 days after January 20th, on January 23rd, all NIH communications were frozen. They were forbidden from communicating with those of us on the outside. All study sections and review panels were canceled. I had a colleague who was actually in Washington, in a study section, and the person running the study section, who again is another NIH employee, but a PhD, went out, came back in again and said, that's it, we're not talking about any more, the study section has been canceled, go home. All the work done by the people writing the grants that study section reviewed, all the work done by those people on the study section to review those grants ahead of time, the effort to travel to DC, by the way, it's a tiny little per diem. We basically do this as an expected service to the community, all stopped. And nobody could tell us what was going on. A few days later, another thing that seems rather wonky happened. They said, we're going to freeze indirect administrative costs. Now I have to get a little bit into the nuts and bolts of how grants work here because it's really kind of important. When I get a grant, I get direct costs for the project I want to work on. And those direct costs include salaries and benefits for my staff, research supplies, that kind of thing. But running a laboratory is a lot more than the direct cost of actually doing some experiments, right? It's a laboratory. It has electricity. It has air handling equipment, major equipment. It has lab and environmental and radiation safety officers. It has regulatory compliance. It has accountants that have to work and make sure that they're monitoring the grant, and the administration that's monitoring it as well. So there are costs associated in that infrastructure. And what's happened over the years is that recognizing that, institutions negotiate with NIH, and this is revised every 5 years-ish, with strict audits, how much do you need to do that? And for a given $100 that I get, an institution, depending on the institution, the nature of the institution, may get an extra 30 to 90. And we call that the indirect cost rate. And the federal government said, no, we're not going to do that anymore. We're going to flat at 15%, $15. Okay? You can't do the work. You physically can't do the work without the money to support the structure around it. So 22 states immediately sued, And there is now a restraining order for those 22 states. But the rest of the states, they're stuck with this. People have been told they can no longer apply for NIH grants in those states. I have colleagues who've been told that's it. Their universities are busy trying to figure out how they can shoehorn some of this stuff into that $100, which means you can't actually do all the work because you can't afford to do it. So this has been an enormous effect. And if we look at this graph, which I found on LinkedIn, this is the inferred negotiated rate. So this may basically, some of it's an estimate. Here's 15%. And each of these dots, whatever color it is, each of these dots represents an institution and how much money they get from the government for this. So this is the total direct costs. And you can see that here around 60% plus or minus, there's maybe 20 or 30 institutions. Those are our most premier biomedical research institutions in the country. So this is going to really hit these people because they get the most money from NIH and they can't afford to do this work. Now I want you to hold the idea about this because we're going to come back to thinking about universities in particular here. All right? The next thing that happened is the grant cancellations. There's been now over almost 1,000 grants have just been canceled across the country. And it turns out that if you look at the titles of the grants that have been canceled, I ran this, you can see, well, health, of course, minority, sexual, HIV, and of course, a number of other words. And if we look at the subject of those grants, of the canceled grants, nearly 30% had something to do with HIV. People, HIV is still a problem. About 25% are related to trans health of transgender people. Now, those are not independent categories. 17% of the canceled grants, they had to do something to do with COVID, which, by the way, we still have a pandemic and people are dying every day from. 3.5% from climate. These are just the ones that were really evident that you could see why they were getting canceled. And the language was, your grant no longer effectuates agency priorities. This is interesting. This language was not available until Trump version 1. The first Trump administration added this because it used to be you couldn't simply terminate a grant except for financial malfeasance or research misconduct, right? But now, agency priorities, that got snuck in the first Trump administration. The New York Times published a list of 197 terms that may be getting grants pulled out for this kind of look, and I just highlighted a few of them here. These are words that apparently if you use this in your grant abstract, you have a much higher probability that your grant is going to get canceled. I want you to look at diversity. We know there's, and I'm sorry, this is a political thing. We know diversity has been a bugaboo for certain parts of our political process. I have a colleague who studies microbial diversity associated with diarrheal disease. He's a microbiologist, all right? He studies microbial diversity, bacterial diversity. His grant's been terminated. His agency did not even know about it. He got a thing from the highest level of the agency. His program officer had no idea. He didn't find out until 10 days after they stopped the funding. Okay? Expression. Hello, gene expression? Yeah. Excluded from the nucleus. Female is a problematic word. So is woman. Male doesn't show up. Our neighbor was in a breast cancer trial at UCSD. It's been terminated. Orientation. I study centromere orientation. Chromosome segregation. Membrane polarization. These are words that are sufficient, which have scientific meaning quite apart from any political DEI effects, which, by the way, are not necessarily a bad thing either, but these are all things that come out. Systemic as opposed to topical antibiotics, maybe? How about trauma surgeons? How many trauma grants are getting canceled? This is what is happening. If we look at where these grants are being canceled, this is in just the first month they canceled 780 research grants. Now, yes, there are processes by which you can appeal, but those are not necessarily working for everyone. And if you're actually studying aspects of minority health or diseases that predominantly impact particular subsections of our population, you're basically out of luck. All right, now we need to talk about the universities in particular. How many of you saw in the news that Columbia University had been challenged by the federal government? All right, most of you. Columbia was challenged under the premise that it was being anti-Semitic, and all of its funding was frozen unless they agreed to certain standards that the government required, including abolishing or changing some of their ethnic studies departments and letting the government decide whether or not they had sufficiently diverse viewpoints being hired. Columbia capitulated. Their funding hasn't come back. As you see, these are all just headlines from the press. Short-sighted and dangerous, colleges warn of budget cuts after all these freezes. An enterprising student journalist at Northwestern discovered that Northwestern is one of the first 5 universities being targeted, including Harvard, Cornell, Columbia, Brown, and Northwestern. Agency staff at NIH have been told to freeze their grants, not pay them, but not tell them that. So what happens when you get a grant, you get funding for a year at a time, but they don't hand the university a check. They hand the university a letter for credit. And the university uses, you spend your money on your project, and the university goes with the letter of credit to draw down. Well, those letters of credit are not being, for many universities, are not being adhered to, and nobody at NIH will tell them that, or why. So what are you gonna do? You got people, you need to pay them, where's the money supposed to come from? So that's one thing. The next thing, this was a headline. Harvard was the next one on the chopping block. And Harvard, having seen what happened to Columbia, said, no, we're not going to agree with this. You don't get to determine by our academic freedom what our policies are. This letter came out last week. This is an internal communication at Harvard Medical School. It says, within the last several days, the university has received letters from most federal agencies indicating that nearly all of Harvard Medical School's active direct federal grants have been terminated. Not frozen, terminated. Harvard Medical School, one of the most prestigious and impactful medical research organizations in the world, and all of their federal money has been terminated. What's going on? J.D. Vance, our vice president, in 2021 said, American universities make it impossible for conservative ideas to ultimately carry the day. We have to honestly and aggressively attack the universities in this country. J.D. Vance, 2021. All right, let's think about broadly what the consequences of this are. This graph shows you in black the first quarter of funding from NIH in 2024 versus 2025. And the first thing you can see is that this graph, the line is much, much reduced for 2025 compared to 2024. That's for new grants. These are for existing grants that are getting their intermediate increments, and you can see those grants are also slow walked. My own grant was up for its incremental payment this year. It was delayed for 6 weeks. Thank God it came through. But given what they're doing, and given that my university is also on the hit list, I don't know that this will endure. But we have basically a couple of billion in new grants, and a couple of billion, approaching a couple of billion in ongoing grants that is not being paid. The worst one is the training grants. There's a subset of NIH mechanisms that are dedicated to training. Postdoctoral or PhD training in particular subjects. I used to run one at USC in the area of chemical biology, where we trained PhD students in chemistry and biology to sort of work on that interface. All right? There's also mentoring training processes. NIH has programs that go into non-major research universities to help diverse students understand research careers and move on. I want you to look at this. This is January 20th. All new training grants were completely frozen. There's no money going into training whatsoever. They've just basically stopped all training mechanisms. The Minority Senate Committee report says that there's effectively, this came out a couple weeks ago, $2.7 billion funding cut in the first 3 months, including a 30% cut to cancer research compared to last year. A 30% cut to cancer research. How many of you have a family member or a friend or yourself who've ever had cancer? A 30% cut to cancer research. Remember, this is your NIH, people. NIH grants plummeting, Trump administration dismantling science. America will pay dearly for this mindless war on science. The administration has proposed a 40% cut in its next budget for NIH. This is the NIH budget. You can see this plummeting line here is what this is where the administration is proposing NIH funding should be going forward. All right. Impounding money, that is the executive refusing to spend money that Congress has approved, is not legal. They are not allowed to do that. However, if for some reason the money doesn't get spent, at the end of the fiscal, Congress can, by a simple majority vote in both houses, Congress can determine that it will rescind the money. You didn't spend it, so we're taking it back. It's called rescission. Slow-walking NIH rewards, they basically created a cut in NIH. Can you imagine a swing state Republican saying, I'm not voting to cut NIH, they didn't spend the money. It's almost impossible at this point for NIH to spend out and bring those grants back up again because they lost an entire cycle before they slowly started study sections and so on again. So that's one thing to think about. This is the Machiavellian nature of this. I know way too much about politics. Now, internally, there's also been cutoffs. Administration firing thousands at HHS and NIH. Hundreds more staff. This has been coming in waves. They've been getting rid of a huge ton of people at the NCI, National Cancer Institute. The clinical center. There are actually patients in the clinical center on trials. They realized they had gotten rid of some of the doctors and had to bring them back because those are patients there. They're not doing blood tests. They're not doing any of the science related to those clinical trials because they fired all the technicians. An NIH intramural scientist says, however bad everyone on the outside thinks it is a million times worse. They are dismantling and destroying everything. This week, just hot off the presses, they decided to ban any funding towards international collaborations. Now, typically, if you've had a grant, say I have a grant, I have a project, and there's a lab in Canada that knows how to do something I need to do my project. So I have a subcontract with them, and I put a little bit of money into their lab so that they can do those experiments for me. Not anymore. Private NIH leaked memos have said that they have a broader America First agenda that wants to reduce US participation in international science. Folks, science does not look at international borders. Disease does not look at international borders. We don't have an impregnable boundary against infectious diseases coming from abroad. We train international scientists. I trained overseas. This is just devastating. And again, this came out just this last week. Lisa will tell you I spend too much time doom scrolling. All right, the human cost. We are creating a lost generation of scientists. The universities that have been put on freezes or are terrified they might have either stopped entirely or rescinded offers to graduate students. We had to rescind some of our offers for our graduate class coming in. Professors, of course, face an uncertain future. I'm going to tell you that in the medical schools especially, and in some research institutes, most of an individual's salary comes from grants. 25% of my salary is from my grant. I lose my grant, I lose 25% of my salary. But in some research institutes, that's 70, 90, even 100%. No grant, no lab, no job. Okay, so this is, and of course, people are terrified, absolutely terrified. Brain drain? Sure. How many of you heard that the EU made a pitch that we're going to, The EU made a pitch of $500 million. NIH's budget is $50 billion with a B. Individual countries, France, Netherlands, have said that they'll try to hire people. France said, we're going to put, $6 to $10 million into that. That's a couple of scientists, really. Will they get some people? Yes. And if I were 20 years younger and not on the cusp of retirement, I would sure as heck be looking to move back overseas. But there is not capacity in Europe for everybody and picking up remember how much of NIH has done to fund biomedical research that benefits humanity, right? But here's one that ought to get your attention. This is from a Nobel laureate at the Scripps Research Institute, and he said, I have been approached with an offer to relocate my lab to China, complete with a promise of 20 years of stable research funding. Okay, what did I tell you? Grants last for 4 to 5 years. There's a 10 to 15% success rate. How tempting is it to have 20 years of guaranteed funding if you move? Okay, so and this could be obviously thought of as a national security issue as well. I've already knew colleagues who had moved to China before any of this started to happen, so we have that going on as well. So, what is actually the point of this? Well, we know that there is an antipathy to universities and an idea that if you cut the mainstream of funding into universities, then you can punish them and bring them to heel for things that you don't like. All authoritarians go after the intellectuals first. They're going to start screening NIH funding opportunities. NIH will say, oh, here's an area of research that we think we should solicit grants in. They're going to screen those for the 197 banned words, etc. One of the most lethal things is they sent, the Department of Justice sent letters to several medical journals and wanted to know if they published alternative viewpoints. Medical journals work like grants, peer review, right? Convergent evidence. You don't get to publish a paper saying the moon is made of cream cheese. You don't get to publish a paper saying ivermectin cures COVID. There is a convergence of evidence against both of those propositions. So this is really quite dark, that they're trying to get alternative points of view. The NIH director, oh, he's a piece of work. He thought, the current NIH director, who was appointed by the current administration, he felt COVID should be allowed to run through the population for natural immunity. He's removed multiple main scientists and a massive staff purge. Now, so they removed directors of institutes, but they didn't want to fire them. So these scientists at NIH, they said, well, you could go to work for the Indian Health Service in Montana. I mean, it's that petty. We have women minorities fired at purge of review boards. Remember I told you about council, the group that decides where the pay line is? They basically fired nearly anybody who's a female or minority off of council, leaving only white men. Scientists have started to leave NIH, of course. Here's our Health and Human Services head. RFK rejects germ theory. Germ theory says that your infectious disease is caused by bacteria and viruses. RFK says, no, it's caused by bad eating habits. He is already told to stop the main lab that studies extremely dangerous viruses like Ebola. He says that they should stop all research. The Vaccine Center has been slammed by contract cuts. And really depressing, it's all cronyism going forward. The HHS has said, okay, we believe in vaccines. We're going to make a universal flu vaccine. We're going to put $500 million into a flu vaccine. Remember, that's how much the EU is offering to try to rescue American scientists. They're putting it in to the lab of a guy at NIH who is very anti-COVID vaccine and is using a 50-year-old technology and claiming that he can make a universal flu vaccine. As someone said, there is incredible work going on. This is not it. $500 million into one person's laboratory that is not peer reviewed. Now, typically, if NIH says we need a universal flu vaccine, they'll have a funding opportunity, they'll solicit ideas from all over, and they'll fund several different strands. No, they're going to give this guy $500 million to use a 50 to 70-year-old technology to make a flu vaccine. That's not science. That's not how we do science. Scientists have been told to scrub all mention of mRNA vaccines from their work. And at the same time this was all happening, I don't know how many of you saw this headline. mRNA vaccine shows promise in pancreatic cancer trial. Pancreatic cancer is one of the least treatable cancers. This trial was so successful with this mRNA vaccine that they shut it off early so they could expand it. You had a question?
What's mRNA?
mRNA is a technology that was used for the main COVID vaccines to program the system, our system, to respond to something so that we could defend ourselves against infection. So it's a technology, but the anti-vax people against COVID really decided they didn't like it, and they made up a lot of lies about it. And now, now they want to stop any of that. It'd be really interesting to see if any of us can get COVID vaccines next year, when the technology has uses well beyond infectious disease. So I want to introduce you, because some of you know that I'm fond of history. There was a Soviet scientist named Trofim Lysenko, and in the 20s and 30s, which was the golden age of genetics, when we really were understanding those principles of Mendel and how they applied to inheritance, Lysenko didn't believe in genetics. And he had the ear of Stalin. And he thought that rather than inheriting traits, as we know now that genetics works, and then that genetics works, he said there were things that you could acquire traits and pass them on. Imagine, his idea was you could do the equivalent of cutting off your cat's tail and all its kittens would be tailless. Okay? That's what acquired technique was. Now, Stalin really liked the idea, and they banned genetics research in the Soviet Union. Geneticists were imprisoned or exiled, and some of them died in prison because they dared to argue against this concept of Lysenkoism. Lysenko was given charge of trying to figure out how to improve crops and so on. Russia had many more acres under cultivation and much more failure, and there was a massive famine. And Russian science, biological science, really has never recovered from Lysenkoism. And this is, I fear, where we're heading. Peter Hotez is a vaccine scientist from Texas, and he wrote a book called The Deadly Rise of Anti-Science. And one of the reasons he wrote that book is this graph from the New York Times a couple of years ago. This is a graph showing deaths, and accumulating deaths due to COVID. And this right-hand half of the graph occurs after the vaccines were introduced. Now, the mRNA vaccine is amazing because it could be deployed so rapidly and changed so rapidly. And what people began to notice is if you look, there's a dotted line in the middle, which is, people still get COVID and they still die today. But if you actually looked at the political bent of different counties and what the COVID death rate was, you could see that in red counties, the death rate kept going up really quite astonishingly level after the vaccines were introduced. And what we know is that those counties were disproportionately not vaccinated because the right wing had decided to make anti-vaccination its thing. Over 400,000 Americans needlessly died of COVID because they rejected vaccination because of this anti-science bent. So we're in a kind of perfect storm here. We know that killing science will strangle the economy. Cuts to biomedical research are going to cost lives, scientific breakthroughs. We're going to have a huge loss here, and as this guy, from the president of the Council of Education said, this will be celebrated wildly by our competitors who will see this for what it is, a surrender of US supremacy in medical research. A self-inflicted wound that, if not reversed, will have dire consequences on US jobs, global competitiveness, and the future growth of a skilled workforce. Now, in the handout I've given you on one side is a really interesting article by a journalist named Josh Marshall, who talks about various ideas about why they're doing this, and I've touched on a few of them. But the other side is what you can do about it. Because this is your NIH. You paid for it, you own it. The first thing is you have to stay informed. I hope I've given you enough information so that you can understand more when you see these stories, what's going on. Read the reliable press. There's also some advocacy groups that really look at reaching out to the non-scientific community. One is called Research America with an exclamation point in the middle. They're really useful for getting information. The second thing, call, mail, email your representatives. All right? Great resource for doing that, 5calls.org. They will help you identify who your representatives are, how to reach them, and they'll give you little scripts for whatever little thing you want. They have a whole thing on NIH and NSF funding, whether you're interested in immigration issues, whatever, they'll have a little description of that. And don't just do it once. They need to hear from you. Do it regularly. Choose a story each time you want to tell, right? Don't try to put it all in one call. Tell them why medical research matters, why you care about this, why you want to see the benefits of your investment. If you have a personal story, if you know someone who's been in a trial, it's been canceled or whatever, tell it. Call them on their Washington number, call them, everybody's got a San Diego office. You probably won't get a person to talk to unless you call San Diego. Some of them really want emails, you can do both. Send an email. They all have contact things. Tell them what you care about. Because somebody in the office is tallying what they're getting. All right? And if anybody is in Darrell Ice's district, please, please, please call him. He's a Republican from East County who's been dodging his town halls. Talk to your friends and family. Because people don't understand what's happening. And they're destroying something that we've built up over the last 80 years. And once it's gone, it's gone. We can't just turn the spigot back on again. Demonstrate if you're comfortable. We've had a number of pro-science demonstrations in the city. There's a big demonstration coming up on June 14th. There's an organization called Stand Up for Science that's there. And vote, people, please. Vote. Vote like your life depends on it. Because it does. NIH saves us. Let's save NIH. Thank you. No, I haven't, but because I just wrote it. So.
I think that send it out.
Yeah.
All the people, because there are guys there that representatives on the 12,000, which representative would be awesome.
Yeah.
So this is happening now. It's also happening in other fundamental science.
Absolutely, yes. The National Science Foundation is just being completely crushed.
Oh, sorry.
Yeah. Yeah, so I mean, I can only speak to biomedical research, that's what I do, but yeah, we're kind of the big kahuna. If they're doing it to this, they're doing it to the physical sciences much worse. Yes, ma'am?
I have about 3,000 Facebook followers, but I was going to make this public so anyone can see it. Do you mind if I publish this talk you gave this morning with a recommendation for people to watch it? I just worry that somehow it might come back on you.
Yeah, you're absolutely right, it might. But I'm very close to retirement. And, there's a lot of really good advocates, but I think there may be even some better advocates out there. But one of the things that I read in an article that was just published was if you're involved in any way with any particular disease advocacy groups, a lot of those folks I don't think are really up to that, and they have a great voice. So anything that you can do, and you go for it. Yeah.
Well, thank you for this talk. I think, talking about this is really helpful. I know having trained at the NIH, being the recipient of NIH grants, more under the Biden administration, not under the Trump administration, serving on study section, and seeing like the funding opportunity announcements, none
Yeah.
was listed. I had a really wake-up call. I was coming back from a international scientific conference. And the taxi driver just was asking me where I was, and I was sort of excited about, and I was telling him a little bit about the meeting. And he just launched into this tirade about what a waste of money this is to, go to these meetings and, pay for science. And I mean, it was just like, I shut up, But I was trying to give some thought into what precipitated this. Do we think that, science is the cure for everything? Are we being like the Corinthians? Are we being like the Greeks? Focus of the forums are to bring a spiritual focus on the secular problems. And I've been very moved by Francis Collins' books on the road to wisdom and how he talks about, we're just not communicating.
I think that, Barbara, that is absolutely key. Scientists did a terrible job communicating during COVID, and we've done a terrible job overall, right? And we aren't high priests sitting on an altar. We're explorers trying to discover. You are absolutely correct. But I do want to also touch on something Barbara brought up. The former director of the NIH, Francis Collins, is a very distinguished scientist and also a very outspoken believing Christian. And he's written several books on how it is not a conflict between science and faith. And I would strongly endorse that anybody who's interested in issues of science to look at Francis Collins' books for that, because I think that's really important. But yeah, we're not blameless. Some of this, if COVID was a precipitating force for a lot of this, that's brought out a lot of anger and a lot of scientists, people whom I admire, like Anthony Fauci, did a terrible job communicating during COVID. Part of this is our fault for not doing a good job on that. But, this is way beyond throwing the baby out with the bathwater. Blair, did you have?
Yeah. Thank you very much for that, Susan. Being a scientist and being on the business side of science, I really appreciate everything that you said. I want to put into perspective a few of the things that you pointed to. I was trained under an NIH training grant at Emory University School of Medicine. That's where I did my doctoral work. Was there. I was given a little bit of, you don't make much, but they pay for your schooling and they give you a little bit of a training grant. Virtually every company I've worked for is based on work that was funded by NIH. The one that brought me to San Diego, Hybridtech, was the first of the independent biotech companies in San Diego. It was formed by two scientists at UCSD under training grants. And how many men here that are in this room know what their PSA level is or have had PSAs done, okay? That's what I did at Hybridtech. Everything there that we learned about PSA was funded by NIH grants up to the point of discovery and identification of that molecule. That's how important this stuff is to everybody everybody in this room. Same thing goes for breast cancer research, goes for ovarian cancer research. All of that is funded by NIH work. So thank you very much for that.
Thank you, Blair. And just a reminder, cancer funding specifically is 30% cut this year compared to last year because of all this.
What is the PSA test? I don't know. I just asked her. So
That was Blair just mentioned. Prostate-specific antigen. It's a measure for risk of prostate cancer. No, that's fine. No, that's fine. Any other questions, comments? Sherry?
This will be the last one. It's just 10.
It's actually not a question, it's just an observation, which is a number of the improvements and discoveries and identification relative to individuals who are deaf has come from NIH funding. Cochlear implants were a direct result of NIH funding. So, it's like, do they actually think that they won't be impacted by what they're doing?
Yeah, exactly. Do they think they won't be impacted? What I hope that I've empowered you to do is to understand more of this, to go out into the community and talk to your networks about, hey, do you know what's happening? This is ours. You know, you don't count people who didn't die sometimes, right? I mean, you don't realize that there are many fewer deaths. Breast cancer, if it's caught early, is much less of a likely to be lethal than it was 30 years ago. No, I mean, these guys are basically saying, we want to stop any research that's going to lead to new cures. We're happy with what we have now. Is anybody happy with what they have now? No, we can do better. It's like saying 30 years ago the only treatment for breast cancer was radical bilateral mastectomy. I mean, it's just, it's such a huge, huge loss. And of course, as I said, also an engine of economic development. Here in San Diego, how much pharma and biotech do we have? That's directly feeding off, as Blair spoke to, coming off of the, work at UCSD, Salk, Scripps, et cetera. Take all that away, you know, you basically destroyed our economy. So please advocate for this at multiple levels. Know who your congressperson is, call them, and do it a lot. They need to hear from you. When I was visiting Congress as an advocate, I met with a very senior old-style Republican from Alabama, and he smiled at us as we gave our little pitch about NIH, and he said, I don't need to hear from you. He said, I need you to go talk to your church and your Rotary, and I need to hear from them. Because if I don't know that they care about it, I don't care about it. All right? So please, do that.
Yeah, we're running late.
Sorry about that. I go on.
So, no, all right. And you.
Susan, I thought this was an absolutely excellent and terrifying presentation. I'd like to see it disseminated as widely as possible. And I'll share some ideas I have. But also, any of you who are not aware of Episcopal Public Policy Network, EPPN, look it up, subscribe. They send out alerts of things that we should communicate with our representatives about. With suggested text, and whoever you are who signed up, they know exactly who your representatives are. You only have to move the mouse around a couple times.
Yep.
This needs to be a YouTube link.
Well, it is.
Yeah, we'll talk with communications about this.
And when the right wing starts doxing us, I hope that you're all going to come defend our votes.
Exactly.
When they start what? Stalking?
Doxing, it's a term they use when things appear on social media and they don't like the person and want to threaten them, they try to publish who they are in order to get more threats against them. It's like what's happening to our judges now. They're getting threats. Yeah.
Okay, I'm going to wrap it up. It's past 10. Thank you all. I mean, none of us wants to leave the room.